Over the next few lessons, we're going to take a look at AP Calculus topic 2.7. There are many trigonometry problems on the AP Calculus exam, so you'll have to remember your trig formulas, special angles, among other stuff. And angles will almost always be in radians. You're going to have to know the derivatives, as well as integrals, when we get there, of all 6 trig functions. The good news is, they're pretty easy to memorize. In this lesson, we're going to learn 2 very important trig derivatives. We can use the definition of derivative along with some trig identities and trig limits that we learned in previous lessons to prove the derivatives of the sine and cosine functions. But in this lesson, we're going to look at it graphically. A graph of the function y equals sine x looks like this. We can get the graph of the derivative by looking at the slopes of the tangent lines. Estimate the slope of the tangent line right here at x equals 0. The tangent line has a positive slope of 1. I'll mark that here in blue. Now what happens to the slope of the tangent line as x goes to pi over 2? The slope is still positive, but starts to decrease to 0. And what happens to the slope of the tangent line as x continues to pi? Now the slope starts to turn negative and continues to turn more negative until x equals pi. At that point, the slope of the tangent line is negative 1. Then the slope begins to increase again to 0 at x equals 3 pi over 2. If we continue this, we see that the graph of the derivative looks like the graph of cosine x. In other words, the slope of the sine graph at each point matches the value of the cosine graph. Notice where sine is increasing, cosine is positive, and where sine is decreasing, cosine is negative. Pause the video and try the same thing for the graph of y equals cosine x. Estimate the slopes of the tangent lines to approximate the shape of the graph of the derivative. At x equals 0, the slope of the tangent line is 0. That slope starts to turn more and more negative until at pi over 2, the slope is negative 1. Then it begins to increase until it reaches 0 at x equals pi. And it continues to increase until 3 pi over 2, where the tangent line has a positive slope of 1. And if we continue this, we get that the derivative looks like the graph of negative sine x. So you'll need to memorize these 2 important trig derivatives. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. And now that we know the derivatives of sine and cosine, we can use them to get the derivatives of the other trig functions. We'll see this in a later lesson after we learn a few more derivative rules. Now let's use what we learned to find the derivatives of some trig expressions. Find the derivative of y equals x plus cosine x. You want to differentiate term by term. The derivative of x is 1, and the derivative of cosine x is negative sine x. Try the next one. Find the derivative of the function y equals 2 times sine x. We treat the 2 as a constant, and the derivative of sine x is cosine x. Let's try one more. Find the derivative of y equals sine x divided by 2. We can rewrite this as 1/2 times sine x. Now apply the constant multiple rule, which gives us 1/2 cosine x, or simply cosine x over 2. We can reinforce the last 2 examples with a graphing calculator. Input these functions, and let's also include y equals sine x. This graph shows the function y equals a times sine x for different values of a. Notice the larger the value of a, the steeper the curve. And the smaller the value of a, the flatter the curve. And at x equals 0, the slope of each curve is a times cosine of 0, which is just a, since cosine of 0 is 1.